Welcome to this installment of the Secure Your DNS, Secure Your Network series. My name is Tim Rooney, Director of Product Management at BT Diamond IP, and the goal of this video series is to break down into bite-sized chunks the many ways that the domain name system, or DNS, can be attacked or manipulated for nefarious purposes, and to suggest defensive measures you can take to better secure your DNS, and therefore better secure your network. In this video, we're going to talk about DNS reflection and amplification attacks. The reflector attack basically utilizes the source IP address of a DNS query that is actually the IP address of the target. So in essence, what I'm doing is I'm pretending to be the target, asking a question of a DNS server to several servers, and perhaps for very large payloads that I know of. And in essence, then the server will then respond to that source IP address, which again is the target, and thereby by sending lots of answers that were unsolicited and in large payloads from several servers, you can in essence create a denial of service condition for the target, where it's receiving just a burst of traffic for which it is unable to keep up with, and in essence denies the service on that target device. So the impact is the targeted host is barraged with these unsolicited answers, and therefore is unable to perform its normal networking functions. So there's basically two forms of this. So you can see how the attacker is reflecting, in essence, off of these DNS servers and using them as the primary ammunition to then initiate all this traffic to the target, and that's the form of the reflector attack in general. A special form of the reflector attack is amplification, and this is where I'm able to then provide just a simple query and provide an answer that is much bigger, thereby amplifying the attack to the recipient, and thereby more quickly taking the target offline in essence. So in our first form of this attack, it leverages open resolvers, and that's really an internet DNS server, a DNS server that's queryable from the internet that is set to enable recursion. So generally in your network, you want to have recursive servers that respond to clients, and the recursive server basically configures that server to go find the answer. Even if it doesn't know within its configuration, it'll go out to the internet, it'll query down the domain tree, locate the server authoritative, query for the question, get the answer, and respond back. So in general, within an organization, it makes perfect sense, but on the internet-facing side, you should not enable recursion on your DNS servers there. They're basically there to just answer questions that it knows about and to just ignore everything else that it doesn't know about, or to respond not found, for example. So they should be authoritative only. You should not have recursion allowed on any internet presence, queryable, let's put it that way, DNS server. So the attacker configures a server, so the attacker is able to configure an authoritative server that he wants these open resolvers to query, and therefore the attacker has control over the size of the answer. So this is really one way that an amplification attack can be under the direct control of the attacker, because they can program in these large responses and be able to have them queried by these open resolvers, which are then happily going to reply to the source IP address, which unfortunately happens to be our target. So by issuing these attacks, it then causes these resolvers to query the authoritative server, respond back, and then they can initiate this query directly using one source, as we showed in our diagram, or these days with all of the botnets out there that you've heard about, probably in the press and elsewhere, they're able to generate a lot more sources of queries, which can be used directly, or in the case of this present video, on a reflection basis, querying other DNS servers. So the use of open resolvers, here we have an attacker where they're basically querying an open resolver. And you'll notice the open resolver then has to query our authoritative server once. However, now it caches that information. So now every time I reinstigate the query, my open resolver DNS server has the response cached. And therefore it's even quicker to respond to the target, and thereby able to inundate that target with those large answers that I've configured on my authoritative server. So my authoritative server only gets queried once for each open resolver, but my open resolver can respond as many times as it's asked for the same question. So the open resolver, again, there's an open resolver project. There's been a lot of discussion over the last decade or so, trying to get people to turn off recursion so they're not participating in that. And there has been a lot of progress there, but there's still more to be made. So please do check to make sure you don't have recursion enabled on your external DNS servers. The second form of attack here is to use authoritative servers. So as open resolvers are diminishing and hopefully go away altogether soon, the other form of this is to actually use authoritative servers. So the attacker configures an authoritative server for a zone they operate, containing one or more of these resource records, the large ones, to get the amplification effect. And then the attacker can issue the query for the configured RR set using the attack target's IP address again as the source IP address, just your traditional reflector type of approach. And then the attacker initiates the attack directly or via the controlled bots, which can issue DNS queries to the authoritative servers, and basically, again, with the source IP address of the target. A variant of this attack is where they can issue queries to public authoritative servers with well-known long answers. So it can actually just query a legitimate website, and that server is just doing what it's configured to do, provide an answer to a query. And if it's known to, let's say, be DNSX signed or have a large set of information, maybe it accepts any queries, which is basically all of the RR types for a given name. Those can be leveraged for amplification as well. So just to illustrate what I mean by amplification, the answer is amplified with respect to the question. So you have a reflection attack where, let's say, the typical query on the order of 50 bytes, a 400 byte response would be an 80 times amplification. So that's basically where you're inundating for each of my 50 byte queries, I'm getting 4,000 byte attack to my target. And this use of such large responses does require the use of DNS extensions, or eDNS 0, DNS extensions version 0 is what that refers to. But that basically extended the DNS message length up to 4096 bytes. So this just enables you to achieve that amplification. So what can you do about it? So as a target, well, who knows if you're ever going to be a target, but you can configure inbound rate limiting. So for a given source, a given DNS server that's hitting you with a lot of answers, perhaps you can restrict your inbound from any given source to a certain level of IP traffic. As a DNS administrator, certainly help to prevent your inadvertent participation in such an attack. So if you're operating external DNS servers, turn off recursion on those internet accessible servers. They should be authoritative only. Implement network ingress filtering. So basically any network, let's say the target's within your network, and if you've got a query coming from an internal IP address, certainly not private, hopefully not, it's not internet routable, but if someone happens to know your public space and you're getting a query from outside with the source address of your public space, this ingress filtering should drop that packet without processing it. So that's one way. Best current practice 38 to implement that, and also reverse path forwarding controls, best current practice 84. So certainly from a networking perspective, you can help try to prevent these source IP addresses from coming in on networks or interfaces they shouldn't be, which can create these reflection and amplification attacks. And then on the DNS server itself, configuring response rate limiting so that you're not participating in a reflection attack to a given another, let's say, public IP space that you're not under your control for filtering purposes. But you can but through response rate limiting, you can limit the quantity of similar answers to a similar set of IP addresses. A lot of the server vendors do it by kind of a CIDR block, like so from a given /24 for v4/56 for v6. So if I'm getting a lot of queries from that address space for the same thing, then you can filter that using response rate limiting to kind of put that into a quota so that you're not inundating the apparent question or query source with a lot of answers. And then of course monitoring your DNS server for query answer traffic volume, so just being able to get a heads up if you are being manipulated as a participant in a reflector or amplification attack. This might be another indicator based on traffic volume to be able to detect that, and that of course requires kind of an ongoing monitoring process and notification of any kind of unusual traffic pattern. So hopefully this gives you a brief overview of the reflection and amplification attack types and some of the steps you can take to help mitigate them in your network.